I'm Alex Grant. With me is Adam Colvin, Charles Powell, Ian Blair, Kelvin Kotancheck, and we are the Future Vehicle Stopping Group with the ECE department, and we are sponsored by SOCOM.
So the problem that SOCOM came with us to try and solve is the issue of U.S. military troops needing to stop vehicles remotely with either hostile passengers or unknown occupants, and needing to do so without having any risk to injure or kill the people in the vehicle and not catastrophically damaging the vehicle. The other requirements that they gave us were that it need to be deployable by a small team of 2 to 4, have a range effective of up to about 600 meters, and stopping in that same distance. And with cost not being a primary consideration, we use those to develop a decision matrix, as you can see here, with all of the factors across the top, with the addition of an environmental factor to indicate how consistent they were under different conditions. And as you can see, each of these has its weighting, with range having a not applicable rating due to the fact that all of our remaining designs after our first phase not having a range above contact, and we had to solve that using another method that we'll get to later. So as you can see, each of these has a rank from somewhere at 0 being a failure to 4 being perfect. Now, the actual methods we had here are all listed with their ranks with weighting. And then the weighted totals are along the right side of the screen, with net being the highest rated total and then going up from there. Now, for the actual solution we ended up selecting, we, in order to solve the range issue, decided to use a drone delivery system to implement these different methods using a 3-pronged attack, attacking the driver, tires, and engine of the vehicle separately in order to have the highest chance of successfully stopping. The top methods for each one of these categories were the net, which is the highest overall, attacking the tires, the denial of senses, specifically for the driver, and the foam to the engine to cut it out, specifically for the engine. Now, each one of these options was lab testable, and we began our testing, but was cut short due to the quarantine procedures.
All right, so here we have our CFD model, which was designed and developed using the ANSYS Fluent. And now as such, our blinding agent here is the fuel oil liquid off in the Fluent database. Figure 1 is a single nozzle and set with the car body going 0 feet per second, and then figure 2 is the same nozzle design but with the car body at 88 feet per second. And then figure 3 and 4 are also similar car bodies set to 0 feet per second. We did this in order to be able to validate our method works at the higher speeds.
For the testing container part, in figure 5, we built a testing container that represents a car's windshield. In figure 6, we built a light sensor from an Arduino and a BH1750 breakout to see how much light gets through the windshield. And in figure 7, to simulate a delivery system, we built a device from an actuator and a syringe.
In figures 8 through 11, we tested our visibility blocking agents. In figure 8, it's black acrylic paint. Figure 9 is used motor oil. Figure 10 is spray-on bed liner. And figure 11 is Flex Seal.
The next steps would be to continue our vision denial substance tests, continue our CFD testing for other fluids and nozzle designs, and to do the practical testing of our other methods of attack.